I am Sai Gourisankar. I am a senior in chemical engineering and Plan 2. I'm from Fort Worth, Texas, but my parents recently moved to Atlanta, so I guess now I live in Atlanta. My dad is a biomedical engineer, and he used to throw around a lot of, always when we ate dinner, he used to throw around terms around the dinner table, biocompatibility or surface science. And this is really boring, and I told my dad to shut up and let me eat a lot of times. But I guess I learned, I guess I was in that environment of science from a young age, and I realized at some point I like math and science, and I like also building things, and engineering is a perfect way to put both of those things together. Chemical engineering is one of the most versatile degree programs. There are chemical engineers working in biotechnology, there are chemical engineers working in oil and gas, there are chemical engineers working in material science and fluid dynamics. And innovation, doesn't just end with developing the product. It continues into how to figure out making that a product useful and applicable to society. Plan 2 and interdisciplinary curriculums like that teach you how to look out on the world and observe how everybody interacts and how to transform what you make in engineering into something that's actually beneficial to society and useful and applicable. Yeah, so I recently gave a research presentation for my Plan 2 thesis where I called what the nanoparticles that I study, the nanotechnology, I termed them nanobevos because under an electron microscope, they look like the Longhorn symbol. So last March, I traveled to a national laboratory, Brookhaven National Labs, and I was able to take our experiments, what we're doing here, and collaborate with physicists there at Brookhaven National Labs and use their X-ray scattering machine, something that we didn't have at University of Texas. And I was able to do that because we are such a big and well-funded research institutions, particularly my groups, Dr. Truscott and Dr. Johnston, that they both supported this initiative of collaborating with another institution. We develop nanotechnology that can target tumors for diagnosis and maybe therapy. We decide from an engineering perspective what design principles are necessary to make this nanotechnology biologically useful and biologically applicable. Can we get good diagnostic properties out of it, and can we make them safe to enter the body and reach the intended target, which is a cancer cell. The University of Texas provides a very, very good value for the education. We have a lot of opportunities here just because we're such a big campus and we're such a good research institution, but at the same time, we're so good at educating undergraduates. The faculty mentors I've had and the faculty that I've learned under have been, not only top class in their specific research fields and their interests, but also top class advisors and mentors and passionate supporters of undergraduate students like myself. After I graduate, I will be biking from Austin to Alaska this summer. And then I am actually headed to Oxford for graduate school. I'm going to do a year in applied math and physics and another year possibly in the same area or possibly branching off into public policy. After that, I'm actually headed to another graduate school. I'm headed for a PhD in chemical engineering at Stanford. So I'm going to have some fun for the next 7 years. I would tell students in engineering first to pick a passion they feel that they're interested in at the very beginning of their undergraduate career and stick with it for 4 years. It really pays off if you work for it for 4 years, and I think that approach can go towards many different things engineering students can take on. So for example, if they're interested in a design competition, they can enter something like chemical engineering e-car competition, or maybe the solar cell. They're building a solar cell car, I think, in mechanical engineering. And if they stick with it for 4 years, I think they'll see the payoff at the end. And I think that's important to keep that perseverance to keep learning, and you'll learn something about yourself and how you approach problems if you stay with something for your entire undergraduate education here.